Marii Skłodowska-Curie and Pierre Curie came together because they shared love to science and research. The French Academy of Sciences and the Polish Foundation for Polish Science have come together through a shared love of supporting science and research. Maria and Pierre spent their marriage working side by side, sharing groundbreaking scientific discoveries. Professor Gryko and Professor Jacquemin have also spent quite a part of their researcher's life working together side by side and are also sharing outstanding scientific achievements. Ladies and gentlemen, my name is Katarzyna Pronobis and it's my great pleasure and honor to welcome you all here at the Marii Skłodowska-Curie and Pierre Curie Polish-France Science Award ceremony. I would also like to give a warm welcome to all guests who are watching us online on the YouTube channel of the Foundation. We are glad to see here today with us our distinguished guests. Please welcome Ms. Lucie Stepanion, Charge d'Affaires of the Embassy of France in Poland, Professor Francis-André Volman, Vice President of the French Academy of Sciences, Ms. Jadwiga Czartoryska, the member of the board of the Zygmunt Zalewski Foundation, Mr. Tomasz Jackowski, also the member of the board of Zygmunt Zalewski Foundation, Professor Denis Jacquemin, our laureate from the University of Nantes and University Institute of France, Professor Daniel Gryko, our laureate from the Institute of Organic Chemistry of the Polish Academy of Sciences, Professor Maciej Żylicz, the president of the Foundation for Polish Science, and Professor Łukasz Niesiołowski-Spano, the dean of the Faculty of History at the University of Warsaw. I also welcome all representatives of academia, jury of the award, and the befriended institutions, as well as the members of the board and the workers of the Foundation for Polish Science and the French Academy of Sciences. I cordially welcome all of you who are today here with us to celebrate the Polish-French Science Award 2024. As you may know, we are here in the columned hall, which is a part of the University of Warsaw. This beautiful and classical interior was not destroyed during the war, it survived. Moreover, a great Polish composer and virtuoso used to visit this place. Any guesses? Frédéric Chopin was also here in this room. Returning to here and now, I would like to welcome on stage Professor Maciej Żylicz, the president of the board of the Foundation for Polish Science.
Good afternoon. It is my pleasure to welcome all of you on today's ceremony. And before we go to the details about this competition and why we are doing this, I would like to share with you a few thoughts about science in general. So thoughts are dedicated to those who think that science should solve the local problems or things like this. No, world-class science has no nationality and is recognized by the whole world. And you have such an example yesterday when the Nobel Prize was awarded to the people from chemistry, and you can see that those people who were collaborating, but also to some extent competing, to have the tools which biologists love to have to predict from this amino acid structure, the structure of whole protein, three-dimensional protein, were from United States, from Great Britain. So the world-class science has no nationality, but the scientists have this nationality. But another thing which reminds me of the situation when I was working at Stanford University, they asked me to select from hundreds of young scientists the best people to do a PhD in the Department of Biochemistry at Stanford, where we have 2 Nobel Prize winners, 15 members of American Academy. So really, the department was really good. And they told me, okay, you must choose the best, the outstanding scientists, but it would be nice if those people are from different countries, from different cultures. So I was asking why I should do this. At that time I was a young, relatively young scientist. I say because only if you have a mixture of such culture mixture, you have the questions which nobody asked before. You have the interpretation of the results out of the blue, and this was extremely important. So I think, well, 40 years ago, already our friends from Stanford know what kind of selections could be. So it is important to work in the international neighborhood and to form teams which are international. Look at the team of Maria and Pierre. They were educated differently. Of course, the higher education they have in common, but they are belonging to the different culture, different countries, and how clever they were and what they achieve. We all know. So this is something which, especially some politicians, do not understand. Why we need to collaborate with the best scientists in the world, and this is something which we scientists are sure about this. So the Polish-French Scientific Award was created to recognize outstanding research achievement developed jointly by a researcher working in Poland and in France. I'm not talking about nationality. Please look, researchers which are working in France and in Poland, and of course such a situation was in the case of the Pierre and Marie Curie, which formed the team in France, but this was international team. And in the beginning of 20th century, actually Poland was discovered by both of them in 1898. So this was just the edge of the new century. So the situation for scientists were very difficult. Not enough money supported by university. Sometimes the private sponsor need to help. Actually, if you look on the history of Marie and Pierre Curie, they got some help from the private people. And today, situation after 127 years is different. We have special agencies which are giving grants according to the assessment which is done by scientists. So scientists give the money for scientists. Again, the politicians don't like this. Usually they don't want to give the money, but they have no idea what could be done with and how to select such a best people. And I don't know, probably a few years ago I was preparing a lecture. I was giving a lecture in the place in the house where Marie was born here in Warsaw, about if such a personalities like Marie and Pierre Curie, or Albert Einstein, or Charles Darwin would receive a grant from the agency which is working now. And after 30 minutes talk, I will spare this. Don't worry, I will not talk about this. It turns out that no way. Those people will never receive the money from our grant system, which is existing now in Poland. Maybe you are lucky in France, but we are creating as an agency obstacles because there are too many people who want to have these grants, too many people who are claiming they are scientists, but they are not. And second thing, we are not prepared to actually sponsor high-risk projects. This is something which, especially when you are using public money, this is extremely difficult. So this is something which we need to change. We need to change whole system, because this system which is working now, at least in Poland, is not working well. Going back to the 2024, to our award, I can tell you that two organizations, French Academy of Sciences and the Foundation for Polish Science, are creating the jury, which is giving us the best from those who applied. And of course, this work is extremely difficult because there are plenty of very good proposals. But I can say that today our Ds are perfectly fitting to our view why we are doing this competition. We would like to promote the cooperation between scientists working in Poland and France, which results in which give the opportunity to have the excellent achievement in science. So the excellence is the criterion for this, and please remember this. And the last one word is about we are giving a modest amount of money for both awardees, and part of the money is given by Zygmunt Zaleski Foundation. We will hear about this in a moment. So we really appreciate your help. Second is, of course, the awardees can do what they want with this money. But one of the ideas which we have is to sponsor the young scientists who want to go to the French group and the French people which like to go to the Polish group. Because from my experience, when I was working at Stanford, when you are building a network of your friends, the network stays forever, and it really helps you to achieve something in science. The networks of people who you trust. And this is something which is extremely important in science. Thank you very much.
Thank you, Professor Żylicz. Thank you for highlighting, among others, the power of diversity and cooperation, and talking about fruitful cooperations. Let me now welcome our next speaker and the co-host of today's event. It's Professor Francis-André Volman, the Vice President of the French Academy of Sciences.
Good afternoon. I would like first to say that I really enjoyed hearing the president of a funding agency, the one in Poland, providing such a remarkable analysis of the shortcomings of the present system and why it should evolve. And I could not agree more with what you just said. Now, as you know, probably, the Marie Skłodowska-Curie and Pierre'a Curie Award was launched in year 2019 as part of a celebration of the French-Polish scientific collaborations. It is now, in fact, it's in third edition, which has proven already how remarkable it is. And this is for at least two reasons that I'm going to briefly mention. The first one has to do with its history. On the proposal of the FNP, the ministries of the two countries, Poland and France, followed the suggestion to create that prize as a one-shot prize that would be awarded to people who are collaborating. What was remarkable was the success of this first initiative. There were dozens of applications that testified of the remarkable dynamics of science in the two countries, and especially in their interactions. So with this in mind, I should be, as the Academy of Science, very grateful to the FNP and the Foundation Zaleski, who decided to take the challenge and to continue that prize for another 3 rounds, of which now we are at the second round of the Zaleski FNP joint initiative. So this is so remarkable that you can have both public initiative from governmental bodies and then private partnership that contribute all together to support and acknowledge the remarkable achievements of some scientists. And to us in the Académie des Sciences, where we are running a few bilateral prizes and feeling that we should support more prizes, this scheme, which is a joint partnership between some private foundations and some public agencies to support this type of prizes, should be taken as a reference. Now, the other thing which is remarkable, as we understand, of course, is that the prize is awarded to a joint effort of 2 teams. It is not targeted to one scientist alone. It's 2 scientists with their teams. And this has the merit of giving the visibility to this way of understanding that joining forces between different teams may provide unique opportunities to reach unprecedented achievements. Here again, the prize, with what it means, is to us at the Académie des Sciences a reference of the fact that we should more often target collaborations when we want to have laureates. Now, talking of the laureates today, for the 3rd edition of the prize, in fact, I just want briefly to mention that Daniel Gryko is the director of the Institute of Organic Chemistry of the Polish Academy of Sciences, and that he has an interest, from what I read, in artificial photosynthesis, which, of course, touched my heart because I've been working on photosynthesis for all my scientific life. But he is very well known for his contribution in the domain of the synthesis and spectroscopic properties of functional dyes. Denis Jacquemin is a professor at the Université of Nantes and a senior member of the prestigious Institut Universitaire de France, IUF. He's a theoretical chemist, and he's very well known for having contributed to a better understanding of which materials are the most appropriate for optics and photonics. Their collaboration is not that recent. It started in 2016, if I'm correct. It has been successful enough to provide a bunch of publications between the 2 teams, which showed that the complementarity worked extremely well, with the group in Poland being, as I mentioned, expert in experimental chemistry, and the group working in France in computational chemistry. The focus of their collaboration is the study of functional dyes through this combined expertise. It has yielded groundbreaking results that we will hear for in a moment from now. I'd just like to cite one of these groundbreaking results. They have shown that, contrarily to the widely accepted rule that a nitro substituent is a universal quencher, which then prevents, of course, fluorescence emission, several nitro derivatives can be used as fluorescence emitters with a quantum yield close to unity. This is really a groundbreaking contribution to the properties of nitroaromatics. Now, in their ongoing project, they're dealing with a novel set of dyes that are also stable radicals and have high operational efficiency. There's no doubt here that we will have again a major advance in the use of functional dyes. To summarize this, I would say by taking the word of Janine Cossy, who is with us and was a member of the jury this year, when she was regarding Daniel and Denis' expertise, complementary expertise, she just said that, when synthesis meets theory, or when theory meets synthesis, you go much faster and you get right away the appropriate molecules with the expected properties. I wish to congratulate our two laureates of today. Thank you.
Thank you, Professor Wollmann. Thank you also for mentioning the name of the Zygmunt Zaleski Foundation for one more time. And now let us welcome the member of the board of the Zygmunt Zaleski Foundation, Mr. Tomasz Jackowski.
Ladies and gentlemen, it's a great honor for our foundation, both of us, Jadwiga Czartoryska and me, members of the board of the foundation Zygmunt Zaleski. We are here to show our appreciation for the effort done by mainly our great partner, Foundation for Polish Science, and we thank them for this effective collaboration. Foundation of Zygmunt Zaleski was created 34 years ago by his sons in Amsterdam, in the Netherlands, and the main goals of our foundation were culture and science. So at the beginning of our activities, we mainly supported Polish library in Paris, but later on we started to include in our support many other institutions, musicians from different organizations. Now it's mainly Symphonia Varsovia, but not only. And the people from different cultural teams, for example, working now on the restoration of the tapestry Arras. It's very well known as the series of special interpretation of the Old Testament in Wawel, in Kraków. It's a very, very difficult work which is done in collaboration between Poland and Belgium, mainly. But the international collaboration for us is the basis for reinforcement of science in the European Union and generally in Europe. Having these teams working on the development of science, we have the basis for the collaboration, much larger collaboration with other countries. So, especially during these difficult days, we thank you very much the teams who participated in this competition, especially those who won the competition, but not only. So we are we are very, very appreciating your fantastic work, and we wait for the results as the example of 2 Nobel Prizes for Mrs. Marii Skłodowskiej-Curie. It's the future, and we wait for this kind of results in Poland. Thank you very much.
Thank you very much, Mr. Jackowski, for sharing with us the wide range of the initiatives you support. We are glad and honored to be one of them. Now it's time to welcome on stage the Charge d'Affaires of Embassy of France, Ms. Lucie Stépagnon.
Bonjour, ladies and gentlemen, chers scientifiques et amis de la science. It is always difficult to speak as the third speaker or the fourth speaker because a lot has already been said, but I will try not to repeat too much. But first of all, I would like to thank the Foundation for Polish Science for the invitation to be part of this ceremony. It's a real honor for me to join you today in this historical room, the first time personally, to celebrate the scientific collaboration between France and Poland, demonstrated through the 3rd edition of the Franco-Polish Marii Skłodowskiej-Curie and Pierre'a Curie Scientific Prize. This award honors joint French and Polish research, strengthening the ties between the Foundation for Polish Science and the French Academy of Sciences, thanks to the support of the Zygmunt Zaleski Foundation. Merci à vous. I would like now to extend my heartfelt congratulations, félicitations, to the 2024 laureates, Professor Denis Jacquemin and Daniel Gryko, for their groundbreaking contribution to organic chemistry. Your collaboration exemplifies the deep scientific partnership between our two countries. And now, if you allow me, I would like to share a French historical anecdote that in its own way echoes the work of Professor Jacquemin and Gryko on chromophore. In August 1901, after being struck by lightning, the Pernod factories in Pontarlier on the banks of the Doubs River in the Jura Mountains were devastated by a fire. These factories produced absinthe, 600,000 liters of liquor spilled into a lost well. 2 days later, traces of absinthe, identified by its golden color with green reflections, were found at the sources of the Loup River, a river apparently unconnected to the Doubs. This revealed a resurgence of the Doubs River. Following this event, the scientists and speleologists Édouard Alfred Martel and Eugène Fournier poured a powerful green organic dye, fluorescein, into the Doubs at Pontarlier and confirmed a few days later its hydrological connection with the Loup River. Let me here thank our scientific attaché at the embassy, Professor Schneider, who is with us, for sharing with us this scientific anecdote and for his engagement dedicated for Franco-Polish cooperation here in Poland. Thank you. As I am a diplomat, I won't elaborate more on your research on chromophore, but I would like to underline that your work has been made possible through significant financial support, and you mentioned already the importance on both public and private finance. This support was came also from the Horizon Europe program. So, as I just mentioned, this European program, I would like here to point out that France considers the battle for innovation and research, as President Macron said in his Sorbonne speech on Europe last May, as one of the pillars for a shared prosperity. Europe needs to be a major innovation and research power. For this, France, we need to reaffirm, Europe, we need to reaffirm the goal of 3% of European GDP assigned to research. The European level is crucial for science and innovation, but today's ceremony reminds us how necessary strong bilateral cooperation is to build network, as you mentioned, President. Scientific cooperation between our two countries is dynamic and continues to flourish. Let me give you some examples. The Uber-Curien Polonium program, in partnership with NAVA, supports 20 new research projects annually. We provide at the embassy scholarships to nearly 100 doctoral students and researchers each year. Collaboration in astrophysics, as seen with the AstroCent lab in Warsaw, and partnership in other fields, such as those between the Centera project and Unipress lab with French University, further highlight our shared commitment to scientific advancement. This year, we also launched a new Weimar Excellence initiative to strengthen cooperation between France, Germany, and Poland. To conclude, I would like to mention that the new bilateral treaty on which we are working on with our Polish friends will include significant provisions for higher education, research, and innovation. This will provide a robust foundation for future collaborations. Once again, I congratulate Professor Jacquemin and Gryko. May the influence of the prize grow in the years to come. And if I may, a last remark, echoing the role in science of Marii Skłodowskiej-Curie and the priority that France gives to promoting women in science, we hope to see women researchers among the future laureates. Thank you for your attention.
Thank you very much, Ms. Stepanią, for showing us the background of the Polish-French relations. Now it's time to ceremonially acknowledge the outstanding achievements resulting from a great Polish-French research collaboration. Professor Żylich, Professor Volman, would you please join me on stage? Ladies and gentlemen, the Foundation for Polish Science and the French Academy of Sciences recognize with the Marii Skłodowska-Curie and Pierre'a Curie Polish-French Science Award 2024 the work on organic synthesis and quantum mechanical calculations of dyes of Professor Daniel Gryko and Professor Denis Jacquemin. Congratulations.
So thanks a lot. It's of course a very special honor to receive this prize. So I want to thank the Foundation of Polish Science, the Zygmunt Zaleski Foundation, and the Akademii des Sciences for choosing us. I can add that this is a special award for two reasons for us. First, it's a collaboration award, as it has been said, and I think this is always a pleasure to receive an award when you can share it. And the second reason is, of course, the names of very well-known chemists. So even if this award can be given to any specialty, as chemists ourselves, I think it's a very special occasion. So we're going to speak a bit about science anyway. So what we are doing with Daniel is to try to optimize new dyes. So dye chemistry is very old. So the first trace of industrial colorants are 4,000 years old. And at that time, this was extracted, of course, from seashells. And this created one of the first ecological disasters, actually, because those seashells almost disappeared from the Mediterranean Sea. But, okay, to have a very French reference, you can know this Caesar drawing in Asterix, and you see his dresses is in red, and this dresses was made with this Tyrian purple dye. At that time, it was 20 times the price of gold. So you see that humanity has been interested in colors for a very long time. The structure, the chemical structure as we draw it now, was only resolved 1 century ago. Another well-known dye is this, alizarin, which is an anthraquinone derivative. To give you an idea of the industrial pressure, the patents for its synthesis were filled by 1 day difference by those German and English gentlemen. And this was before extracted from plants in France, and this famous red trouser of the French army at the start of the First World War. And this, because of organic synthesis, was so effective, then this created also economic crisis. But what we are interested in with Daniel is fluorescence. And fluorescence is a phenomenon which is a bit different, where the molecule gives you back the light it absorbed. You can find it in mushrooms, in fishes, in Scorpio. So at late evening in the desert, you can see blue spots, and these are the Scorpio. And of course, also in a jellyfish. In general, you can see that the molecules are very different, even if you are not a chemist, but they share similar characteristics. In the biological world, the emission of light is typically very ineffective. So as chemists, we try to make it more effective, I guess. And we wish to target applications. So just to give you a few examples of possible applications. Imaging, so here it's imaging fingerprints, but it can be also imaging some kind of cells or some kind of diseases. Detection, so detecting a special analyte in water, for instance, to know if some toxic chemical is present in some water. White light emission, so here we are really under strong light. To create white light, you also want this type of fluorescent dyes, and you can have plenty of applications. And finally, security ink. So in all your banknotes, there are some fluorescent dyes, of course, much more effective. Maybe we can show?
We did already.
Okay, so you can see a demonstration of what Daniel is able to do on the right-hand side. So as a theoretical chemist, we try to understand what happens. So when a molecule gets excited by external light, it can do plenty of things. But generally, as human beings, once you are excited, you want to go back to the ground state, you want to relax, right? And this way to relax, this emission of light by fluorescence is only one of the very few ways that the molecule can relax. So we can draw complex diagrams to explain the different pathways, and as a theoretician, I have to quantify it. The idea of the collaboration is to maximize the efficiency. So here you basically have the ratio between what is useful, the fluorescence, and what is useful plus non-useful. At best, this is close to 1, and this is what we want to reach. And the example I gave you before on the biological systems were very ineffective. So in the Scorpio, it's like 1%. So only 1% of the light is absorbed, is given back to you, though you still see it. So we try to model this kind of surface, which is like the way we see molecules as a theoretician. So I will just say that for this, we need to solve complex equations. We need to model the experimental spectra. And we have this kind of equation. So the idea here, I hope this will work. Oops, yes. So the idea here, just the difficulty, and you don't need to be a chemist, is the cube there. So this is a very nonlinear process. So the intensity that you receive is cube power of a relationship with the energy. So this means that it's quite complex to model because you are not in a linear regime. I can just give a very short example of one thing that we did with Daniel. So this is a series of dyes synthesized by the group of Daniel a few years ago. And you can see that they all almost look the same, right? Only the bottom part of the dye, oops, I don't see, I cannot make it work. Only the bottom part of the dye are different, yet the quantum yield, the efficiency goes from 70 to basically 0%. So this is very different efficiency. So we try to understand that, and I just show you one case that works. And in this case, the theory is reproducing the experimental spectra very nicely, and also is reproducing the quantum yield. So you see that Daniel measured 68%, and we compute 71 or 77%. So this is an example, let's say, that works. And to give you another example, so this die that is basically very similar to the previous one, that looks very similar to chemist, is totally different in its shape, it's totally different in its spectra, again we can reproduce that, and it's totally different in its efficiency. So here experiment is 1% and theory is between 1 and 7%. So this gives you an example of where we are, and we of course wish to go further than that.
Yeah, in order to study the properties of the dyes, first we have to make them. And let's be honest, not all discoveries are made by pure design. It's been like that already since Bayer time. So when Bayer discovered fluorescein, he didn't mean to discover fluorescein. He just put two reagents together, the catalyst, and he hoped for the best, and he discovered a dye which is still in use even today. Fluorescein is used massively by molecular biologists. And now it's, I think, 150 years later. In quite a similar way, in 2012, we discovered this multi-component reaction, which you can see. This reaction is presented here because it provided our collaboration an amazing platform. The simplicity of this multi-component reaction in terms of making it is really fantastic. Just to give you the example, people in the University of Copenhagen in Denmark, people at the age of 20, when they start first practicum curriculum in organic chemistry, they started from making this dye. So they are completely unexperienced, they only know chemistry from the books, right? And they start with this synthesis and it works. It was introduced to the practicum, let's say, practical aspect of organic chemistry in Denmark. At the same time, these three agents, they are put together. So it's 5-component reaction. There are not so many of them. This is one of the uniqueness. And the compound is very, very fluorescent. So whatever we do, we can change all of these elements. But this is everything, regardless what we do, everything is highly fluorescent. One practical aspect, which I would like to emphasize for these dyes, is that unlike many other achievements of other research groups, this can be performed, and routinely is, on the scale of over 10 grams without any chromatography. That means that in principle, we could even use it for these highlighters. We don't, because this is a relatively cheap application, already highly optimized. There's not really much we can do. But we could because it's so inexpensive. They are not amazingly stable. And that's why Dr. Mariusz Stasiuk, present at the audience, came up with the idea to make them more stable by introducing pyridine ring, which you see in the middle, and then boron atom. Using this methodology, we were able to transform very unstable dyes into very stable dyes. And you can see the element of the stability on the right-hand side of the presentation with this horizontal line. Horizontal line means that after irradiation with light, quite powerful light, the compound is still itself. It doesn't decompose over the period of, let's say, a few hours, which would be enough for the molecular biologists to use even in the long-term measurements. At the same time, emission is well above 600 nanometers. So if you imagine the whole part of light which we see with our naked eye from 400 to 700, the best part is far away in the infrared. But if we are not there yet, the second best part is around 700. So then it's around red color. This red color is of the fluorescence as the right-hand side, from your side, yeah, it's right-hand side. This is what molecular biologists like the most, because it allows the light to penetrate deeper. So you can excite something a little bit deeper into the tissue than just a single cell. Diketopyrrolopyrroles is another topic on which we worked in the past. These are pigments which we all know from our life. So who at the audience has a red car? Please raise your hand. Who has a red car? Well, it looks like a red in Poland is not popular. Okay, but no, some people outside of the room have red car, right? These days, almost all red cars have so-called Ferrari red as a pigment. And Ferrari red is one of these diketopyrrolopyrroles. They could be modified, And we introduced one of the modifications in 2012. When you modify the structure, you also modify the fluorescence. So we can change the color of the fluorescence of the light by changing the structure. And using one of those, in 2020, together with a German professor of photophysics, Dirk Guldi from Erlangen, three of us and our younger coworkers discovered the way to essentially, as it was mentioned already by one of the previous speakers, how to make nitroaromatics fluorescence. So the big advantage of the nitro group is that it enhances the stability of the dyes. So if you can make nitroaromatics fluorescent, which usually is not the case, we could go towards stability. And stability is important in all possible applications. So the compound which you can see on the right-hand side, yeah, it's here, it has two nitro groups, and even though in the nonpolar solvent it displays almost quantitative fluorescence. That means if the molecule absorbs 100 photons, it emits, let's say, 95 of them. So it's very efficient. These type of studies enable us to create certain rules, like for the future, for us or our competitors or our colleagues, how can we make nitroaromatics fluorescent in the predictable manner? And this is, in fact, the future of our collaboration, to switch from post-factum rationalization of the photophysical properties to prediction of the photophysical properties. I will come back to that in a second. I'm showing few pictures. I'm not going to go into it because I know that many of you, well, are not so deeply interested, for example, in all the transition or on the excited states. But together with Denis, we are able to explain why in this particular case the nitro group does not quench fluorescence using both photophysics but also computational studies. Yeah, so we are able to establish the rules. And one of the major rules is that the compound needs to have certain charge transfer character, but not too much. Of course, it's a very relative rule. One can argue, well, that what means not too much? It depends to be, it remains to be, let's say, quantified in the future, hopefully. Anyway, now we can, in a more predictable manner, design these dyes on the paper and then make them in the lab. And then, in many cases, in fact, they are already more or less what we predicted by the rule of a thumb. If there's not rule of a thumb, then Denis and his co-workers, they compute these compounds, and then they can give us the exact prediction. So, for example, I get email from Denis, like, you know, this compound should emit red light, and intensity should be strong, or moderate, or very weak. Yeah, and then we make it. So this is the future. This is the future for many reasons. One of the reasons is efficiency. You know, imagine if we can make on the paper 100 molecules, that takes maybe, well, okay, 1 hour, right? Then for computing, it takes, let's say, a few months. But if we would like to make them in the lab, it takes a few years. And most of them will be the failures, statistically. Yeah? So if we can have a prediction first, then it's much more efficient for the future. The only issue is that organic synthesis is difficult. Organic synthesis is difficult, and I remember the case already from 2020 when I asked Denis to compute certain analog of the known dye from our lab, discovered, by the way, by Dr. Marii Skłodowskiej-Curie, who is also at the audience. And he computed it, and it was very promising. And then we spent 2 years to make it, and it's still not made. So this is one of the problems, that sometimes we have very good prediction, and with huge effort, experience, and devotion of members of the group, we still cannot really make this super promising dye. Yeah, so that's exactly what I said now. So we would like to be able to predict it. At the moment we have, let's say, hybrid approach. Sometimes we design, predict, and make. Quite often we design, predict, and we cannot make. So in fact, majority of papers are about the post-factum rationalization. A few words about the collaboration. So the collaboration started from 2016. I have to give full credit to Denis because he contacted me to propose this collaboration. And he quickly visited me in Poland, so that sort of cemented the whole fact. At the moment, we have 21 joint papers, but I expect the 22nd to be accepted in 10 minutes, actually. And we have 5 more manuscripts in the preparation and around 10 in, let's say, computing and doing. So probably this number will almost double until the end of the next year. This is a good moment, I think, to acknowledge people. So we both would like to acknowledge our group members. I don't like to read all the names, but I would like to use this occasion to acknowledge in names my 4 research assistants. Dr. Bata Koszana, Dr. Mariusz Stasior, Dr. Żenia Poronik, and Dr. Olena Wakuliuk, who are with me already for, well, at least 14 years, sometimes even almost 20. And these days, when I'm director of the Institute, traveling quite a lot, discussing the future of Polish science, very difficult subject these days, they are really running the group. They are teaching the next generation, which is also present at the audience. So I would like to thank you very much, and also all the other group members and ex-group members, and in particular from the people who are present, Dr. Marii Skłodowskiej. I would like to also thank many collaborators. The number of collaborations which we run at the moment is overwhelming. It's over 30 active collaborations. So there's no place to put them. That's why I put people who are either at the audience or could be, if they would be not sick on the holidays, Dr. Jolanta Perasińska, Dr. Marzena Banasiewicz, Dr. Antoni Wrzosek, Professor Bolesław Kozlankiewicz, Professor Andrzej Sobolewski, and Dr. Olaf Morawski, so most of them are also present. And also I think Denis would like to thank his group members.
Yes, so of course I thank all my group members that you see there. I want to say that the people at the bottom of the list are independent researchers, so we are really jointly working. They are not really working in my group. And the majority are female, so there is hope that future awards will not be male only, as it was mentioned. So thank you.
Yeah. I would like to also thank my family, which is here represented by my daughter. So thank you for being patient. I think I managed quite well, but of course I would be more often home if I am not myself, right? So this is basic true. I would like to thank my parents who are not present, but more I think about that. When I started my experiments at the age of 13, working with compounds which are toxic, in the middle of the living room, you know, that takes some courage from people to allow the child to do that, right? And they allowed me to do that for a decade. Yeah? So I continue to make these experiments at the living in the living house in which people live until I was essentially finishing my undergraduate study. And of course, I would like to thank my wife, who unfortunately is now, I mean, fortunately for her, but unfortunately for me, she is now on the important trip abroad. And having, I think, 2 more minutes, so Professor Żylic, during his speech, mentioned about some challenges in Polish science. In my opinion, one of the major challenges, besides the mentioned already, is certain delusion which we have. Now, when I make these experiments at the age of 13, I didn't expect to get paid, of course. And also, because it was like a passion, it still is, right? We all get, I think, under the illusion that because it's a passion and we would like to change the world, it doesn't have to be well paid. And it worked. It worked. I mean, these people behind us, I guess, if you check, they were not really well paid. And all people in Poland who've been to our little museum in the new city, they know that initially they work in a thing which I would call a barn, not laboratory. Yeah? But the world has changed. Unemployment rate in Poland is the lowest in the history. And I think we should think about changing our perspective. Yeah? Because we are talking a lot about evaluation, checking. Imagine that you put Enrico Fermi, Marii Skłodowskiej-Curie, Pierre Curie, and Albert Einstein into one group. You don't have to check them every 5 years, right? Because they are passionate and smart. It's almost certain they will do something. Yeah? So I think in the current situation in Poland, and probably also in France, the only future is to move 2 steps forward. So at the moment, we are on the level like the government tries to make the salaries not tragic. With moderate success, but recently some success, right? The next step would be to make them, let's say, okay, yeah, okay. But this is still not enough now. I can tell you, talking with people at the age of my daughter, or my daughter exactly, her boyfriend, other people, will not encourage the best Polish minds to that job paying just more or less acceptable salary. This is not going to happen for this generation. I'm absolutely certain. Yeah? We have to move this job to the level of attractive salary. It can be still lower than in business because people in business get, let's say, it's a different logic, but it cannot be 3 times lower. Right? So that's my vision for the future of Polish science. Of course, the government is not entirely on our side yet, but maybe together with Professor Rzecz we'll be able to convince them that in order to ensure that the next generation will join this, but with the best minds, not with someone, just someone, we have to change this financial vision for the remuneration. Thank you very much.
Thank you very much, Professor Wollman, Professor Gryko, for showing us behind the scenes, the colorful life. It was a great pleasure to feel your passion and courage. Ladies and gentlemen, the official part of our ceremony is coming to an end. A warm thank you goes to all guests, also those watching us online, as well as partners and organizers of this ceremony. Thank you very, very much.